Doug Slocum, Naval Architect at Kelson Marine up in Portland, Maine. Last week, I had the honor of attending the Ocean Renewables Summit that was part of the programming at an IPF put on by Oceantic. I was also further honored to be on the panel talking about supply chain crossover between offshore wind and ocean renewable energy. Jason Cottrell of Sparrow was our moderator as during the panel with Robert Langsford of American Brewer Shipping, as well as Jan Matheson of Carbon Trust. We had a great conversation, so I'll kind of walk you through it real quick. So at Kelson Marine, we focus on bringing model-based engineering to the blue economy. We have years of experience analyzing the ocean conditions and designing, modeling, and analyzing these really dynamic, flexible structures in the ocean, largely aquaculture. But I lead our renewable energy projects here at Kelson, whether it be wave energy, hydrokinetic, especially tidal energy. We're also looking to move into floating solar, floating offshore wind, to name a few. I'll come back to this project in a little bit. As much as possible in our work, we also like to leverage hyper-realistic techno-economic analyses. What that means is that we're designing and optimizing the design of a system, whether it be aquaculture or renewable energy, not only for the initial CapEx purchase and installation, but also the operations and maintenance of the system over its lifespan. So a good example of renewable energy might be you're trying to weigh between what gearboxes to use in your power takeoff system. And with these TEAs, we can actually capture what your maintenance cycles look like and what that means for your operational costs down the road. So we try and use that whenever we can. We also have some traditional naval architecture skills in terms of manned and unmanned vessel design. So in all of our projects, we try and get a really thorough understanding of the conditions at a given site or series of sites that are being considered. So what do I mean by that? We take time history data, whether that be hindcast models, deployed sensor and buoy data, et cetera. For example, here we have about 22 years of current and wave data in the Gulf of Maine. And not only do we look at normal operating conditions, but we really specialize in extreme event analyses, getting you those details for what are the 25, 50, 100-year storm conditions. Just as a little bit further example, what we have here is this 3D surface that shows the 50-year return conditions in terms of waves and current. And the little red triangles are what the standard industry design practices dictate that you shall use in terms of 50-year waves and 10 years current and vice versa for the combination. And what you see is that they're actually well outside what you get when you look at all of the phenomena together in terms of waves and current for 50-year return. So not only are we getting a really good detailed picture of what are the driving physics at a site, but also we can design to industry standards, but also can help influence those standards too down the road. So moving on to some of our recent renewable energy projects where we apply a lot of that meta-ocean analysis, this wave energy converter has been a really fun project where we have two thrusts happening simultaneously. The first is a tank testing effort where we're working on proving out a novel control method for this multi-body WEC. Concurrently, I believe the design of a larger similar WEC that hopefully, if all goes well, will be deployed out of PackWave. We're going to try and prove out that same control methodology, in the open ocean. It's been a really, really cool project working with our partners at Marquette University, Littoral Power Systems, and GE Vernova. Really hoping to get back in the tank for our final session because GE Vernova is an MPC controller, which is in turn based on some of the validated hydrodynamic models that we've built at Kelson, is shown some real promise. Over a 10% increase in energy produced and a 20% reduction in peak PTO loads just by changing over to that control methodology. Some really cool results and hoping to prove it out in the tank. Another recent project we were involved with is the design of a hydrokinetic turbine platform. Kelson in this one was the system integration role, the platform design lead, as well as the mooring and anchoring approach design leads, doing a lot of dynamic modeling of all these systems. We worked with our other design partners on the team, subsystem and subject matter experts, to basically go from a napkin sketch to a just about ready to prototype system in about 2-month turnaround, which is pretty fast. It was a really cool project, though. So those are just some of the things that we've been working on in the renewable energy space. In all of these, we leverage system integration to really ensure that your system's functional, whether that be mechanical engineering, all the subsystem tracking and tracking, especially their interconnections, whether those be physical plugs, piping, all those things, but also in terms of data flow and power types and those things. So when you start bringing all our subsystems together, we have some confidence that they'll work. Another key thing we do is open water deployments with instrumentation. So what I mean by this is we deploy sensors that capture the driving physics, waves, current, wind as necessary, and then also key things that we're trying to learn about, say, either aquaculture farm or the a renewable energy platform. So we'll put out load sensors and moorings and other structural elements. We'll put out motion tracking for key parts of the system. What we do is we deploy that for as long as we can, and then we take all the data back in-house and then use that to refine and validate our models, make sure that our models are tracking with what is happening in the real world. So in terms of supply chain crossover from offshore wind to ocean renewables and vice versa, from the design engineering standpoint, I think there's quite a lot that can inform both, whether it be the meta-ocean analyses I've talked on, the technology development of the technology itself, proving that out in controlled environments like tanks or wave flumes, and then also open ocean testing for sure. Could also help with co-location of these, whether that be offshore wind co-locating with aquaculture or other renewable energies. And there's a lot of different ideas we have for what that co-location of offshore wind renewable energies might look like, whether you combine a WEC and a turbine into a single floating platform, or if you have them at least in the same permit space, sharing moorings, etc. So there's a lot of different flavors of that. Also, we are a timber facility, so we can help any early stage technology developers get your system designed and into the ocean. So if that's of interest, please feel free to reach out. I'll try and briefly go through the Q&A recap real quick. We had a really good discussion afterwards. Yeah. So one question that was posed to me was, what was the crossover of hardware between offshore wind and ocean renewable energies? And I treat this as a by subsystem type thing. So thinking of the subsystems on offshore wind, your anchors are definitely transferable. Your dynamic and static cabling, all your power transmission, any substations, that's definitely transferable between these sectors. Moorings are, I think, largely transferable. That really depends on the mooring type, whether catenary or tension leg, etc. One caveat I'll give to that is on wave energy, your device performance can be really heavily impacted by your moorings. So you need to take that into account early in the design stage. So as far as other things like power takeoffs, there can be some crossover. I think there's just a little bit less because of the kinematics of a wind turbine versus the mechanics we're dealing with for ocean renewables. Not to say that there isn't potential, just I think it's not as fluid a transfer, I would say. I do see ocean renewables potentially adopting some of the lessons learned from especially floating offshore wind in terms of platform design. So I'm in structure design specifically, so seeing more materials and build approaches using things like spiral welded steel pipe, concretes, etc. I wouldn't be surprised if here and there that makes some more appearances. Another question I got was, what is the state of wave energy? And I like to say it's the Wild West, mainly because there's not technical consensus on how a WEC should work in a given wave environment. In terms of how what your hydrodynamic bodies are, how they interact with the waves, how those hydrodynamic bodies then in turn interact with your power takeoff system. There's a lot of different flavors across the world. There is some that are either going into or coming out of some pilot programs worldwide, but I would say we don't have any commercial adoption yet. That also makes it a lot of fun. There's a lot of research. There's tons of research going on in terms of control methodologies and what those open or closed control loops look like for WECs. So that's been pretty cool to be diving into. But yeah, no one has agreement on what a mooring system or the bodies or the PTO should look like for wave energy. And finally, there is discussion on the supply chain, specifically regarding labor and how you train up that labor. We had some really good discussion, and the other panelists had great commentary on the transfer of ports and vessels and just human skill and talent from offshore wind to ocean renewables. I agree that's definitely transferable. On the design engineering side, one thing I've seen is STEM outreach in the collegiate sense seems to be really drawing some attention in and also some excitement for marine renewable energies. So things like the NREL's Marine Energy Collegiate Competition, or MEC. I recently heard a grad student attribute competitions like that or similar for offshore wind for why they want to go work at PNNL now and I believe have a job there. So just things like that, like just letting engineering and design students know that, hey, this is a industry and you can go do these things. I think would be great outreach for training the engineering side of this workforce up. So yeah, thank you very much for your time. And if you have any questions or want to know more about anything I described here, feel free to reach out. Thanks.